Here's how lighter motors change electric cars. Current electric vehicles carry heavy battery packs to make up for motor inefficiency and weight. Carbon nanotube motors cut motor weight dramatically. This means car makers can use smaller, lighter battery packs while keeping the same driving range. Cars become lighter overall and need less energy to move down the road. Current limitations hold back electric planes and long-range drones completely. Traditional motors are simply too heavy for aircraft that need to stay airborne for long periods. A drone with copper motors might fly for 20 minutes before the battery dies. The motor weight forces engineers to choose between flight time and carrying useful equipment. Electric planes face the same problem, but on a much bigger scale. Heavy motors require enormous batteries that make the aircraft too heavy to fly efficiently. Carbon nanotube motors make electric planes and long-range drones much more practical. The weight reductions that matter most in aviation are the very gains this technology promises. Small electric aircraft could fly between cities without stopping to recharge. Cargo drones could deliver packages across long distances. Personal flying vehicles become practical when motors weigh much less. The weight savings make flight possible where it was impossible before. Flexible carbon motors open up completely new design possibilities. Engineers can weave these motors into clothing or curve them around unusual shapes. Smart clothing could have tiny motors built right into the fabric. Medical devices could wrap around body parts instead of being bulky and rigid. Robots could move more like animals instead of mechanical machines. The flexibility changes what's possible when designing products that need to move or vibrate. The efficiency gains create another layer of benefits. Carbon nanotube motors conduct electricity about 130% better than copper motors in some tests. This means less energy gets wasted as heat and more energy goes toward actual motion. Devices run cooler and don't need big cooling fans or heat sinks. Phone batteries last longer because the vibration motor wastes less power. Electric tools work longer on the same battery charge. Less waste heat also means motors can be packed closer together without overheating problems. Consider two key areas where this matters most. In aviation, drones and aircraft benefit enormously from the 80% weight reduction because every ounce counts for flight time and payload capacity. In consumer electronics and medical devices, the improved conductivity means surgical robots could have more precise movements, while heart pumps become smaller and last longer inside patients. Manufacturing costs could drop once production scales up. Right now, making carbon nanotubes requires expensive equipment and careful processes. But mass production typically brings costs down for any new technology. Car companies could build electric vehicles that cost less than gas cars. Consumer electronics could become more affordable while offering better performance. The economics work out when millions of motors get produced instead of just laboratory samples, but the change is an instant. Manufacturing scale, alignment precision, durability challenges like oxidation and moisture risks, and cost are current barriers that must be solved before mass-market cars or planes adopt these motors. Korean researchers solved a fundamental problem that stumped engineers for decades. They figured out how to make motors work without metal coils at all. This breakthrough removes the basic limitation that forced engineers to choose between light, efficient, or cheap. Carbon nanotube motors can be all three at the same time. The implications reach far beyond just better performance specs. This technology could reshape how people interact with everyday devices in ways most haven't even considered yet. The breakthrough shows real promise, but faces real challenges. This could be one of the biggest changes in motor design in a century, but it's still early stage and in the lab for now. Picture an electric car with a much smaller battery or a drone that flies far longer. These improvements become possible when motors weigh 80% less and conduct electricity better than copper. The technology is currently in an in-between phase. It's too advanced for everyday use, but too expensive for mass production right now. Major companies are still testing these carbon motors in their labs. Carbon nanotube motors offer three key benefits. They're lighter, more efficient, and flexible. But manufacturing scale, durability, and cost remain major challenges that researchers must solve.